Hari Om. Hello everyone. I am Sri Jyoti. Welcome to my channel. Today's video is of class 11 mathematics, chapter 2 relations and functions part 2. So make sure that you have watched part 1, that is relations. Today we are going to study functions and types of functions. Functions is very important in mathematics. Why it is so important in mathematics? The topic calculus, which is most applicable in many fields, is about functions. Okay, and it is the special type of relations. Okay, so function is the relationship between input and exactly one output for each input. That is, each input has exactly one output. That is the function. Okay, so that is x. Take x as the input. Okay, some operations happening and we will get f of x as the output. Okay, so here x is the input, and here it performs some operations, and finally we will get f of x as the output, or we will call y. Okay, it is the function. In mathematically, a function is to be defined as let a and b be two sets. Okay, a subset f, okay, a subset f of a Cartesian product A cross B. Okay, Cartesian product we studied already. Cartesian product A cross B is said to be a function. Is said to be a function if, okay, here A and B are two sets, a subset, any subset, okay, a subset, all the functions are subset of A cross B, okay. So a subset of f of A cross B is said to be a function if for each x belongs to A. That is, for every element of A, okay, for every element of A, there exists a unique element y belongs to B. Okay, there exists a unique element, okay, that we called exactly one output. Okay, so a unique element y belongs to B. Okay, y belongs to B such that ordered pair xy belongs to F. Okay, so in mathematically, a function is to be defined as let A and B be two sets. Okay, a subset f of A cross B is said to be a function if for every element of domain. Okay, that is a function from A to B. Means here set of all elements of A is called a domain, right? Set of all the elements of B is called a codomain. Okay, so here for every element of domain has unique element y belongs to B such that how xy belongs to F. Okay, ordered pair xy belongs to F, or we can write it as we usually denote it, f of x is equal to y. Okay, xy belongs to F, or we can write f of x is equal to y. Here x's are all the elements of domain and y's are all the elements, not all the elements of B. Okay, but x's are all the elements of A. Okay, because every element of A should be one output, that is image. Okay, here x is the element of domain and here y is called the image of x. Okay, y is the image of x, x is the pre-image of y. Okay, now here, for example, let f of x is equal to 2x. Okay, let f of x is equal to 2x. Now, I will write let A is equal to set 1, 2, 3, 4. Okay, let B is equal to 2, 4, 6, 8, 10, 12. Okay, now here we can write the elements of the function. Okay, see, function is defined as f of x is equal to 2x. Okay, so what are the elements of the f? Okay, or elements of the function f, that is, okay, see here, when we put x is equal to 1, we will get f of x is equal to 2, right? When we put x is equal to 2, we will get f of x is equal to 4. So we can write the elements here. First x, okay, all the first elements from domain, okay, that is x element. Okay, so 1, when we substitute x is equal to 1, we will get f of x is 2, okay, 2, 4, 3, 6, 4, 8, okay, that's all. Okay, so these are the elements of this function. Okay, in diagram, see, here two sets A and B. Okay, so the function is f of x is equal to 2x. Okay, here 1, 2, 3, 4. Here 2, 4, 6, 8, 10, 12. Okay, that is 1 to 2. Okay, so when x is equal to 1, f of x is 2. X is 2, f of x is 4. When x is 3, f of x is 6. When x is 4, f of x is 8. Now it is a function. See how it is a function. See, every element of A, that is domain. Okay, set of all elements of A is called domain. Okay, set of all elements of B is called codomain. Okay, so here every elements of domain has only one image in B. Okay, every element of A has only one, that is unique image in B. Okay, that is the function definition. Okay, so here, okay, that is the function. Next, types of function. Okay, we will study types of functions. So okay, this one you understood, right? Set of all elements of A is called domain and the set of all elements of B is called codomain. And here it is the range. Okay, that is, see here domain is equal to 1, 2, 3, 4. Okay, codomain is equal to 2, 4, 6, 8, 10, 12. Okay, then what is the range? See, range is only 2, 4, 6, 8. Okay, the range is those who have pre-images. Okay, that is 2, 4, 6, 8. Okay, domain, set of all the elements of A, codomain, set of all the elements of B, and range, those who have pre-images, set of the elements, those who have pre-images is called range. Okay, and here 1 is the pre-image of 2. Okay, 2 is the image of 1. Okay, remember. So next we will study types of functions. Types of functions. Types of functions. First is one function, one and many one function. Okay, one and many one function. See, on seeing the name, we can understand one function. That is, one function means every element of domain. Okay, that we know, right? Every element of domain has only one image in B. That is called a function. Okay, so one function means every pre-image. Okay, every image has only one pre-image. Okay, that is called one function. Okay, see, suppose I will write here. Suppose, see, it is a function, right? It is also a function. Okay, but it is not one function, because This pre-image 8 has two images 4 and 5. Okay. So what is one function? Every pre-image, okay, every range, okay, all the every elements of range has only one pre-image. Okay, every image has only one pre-image. That is, we call it as, suppose say f from a to b a function. Okay, and here if f of x1 is equal to f of x2, okay, f of x1 is equal to f of x2 means it is the element of image, okay, that is elements of codomain. Okay, f of x1 is equal to f of x2, then x1 is equal to x2. Okay, if f of x1 is equal to f of x2, if two elements are equal, means if two images are equal, then its pre-images are equal. That means every element or every images have only one pre-image. Okay, every image has only one pre-image. That is called one function. Okay. See here, for example, here this image 8, okay, 8 has two pre-images, right? Therefore it is not one function. Now see, it is one function because see, all the images have only one pre-image, right? See, 2 has 1 and 4's pre-image 2, 6 pre-image 3, 8 pre-image 4, 10 pre-image 5. Okay, so what is one function? Every image has only one, that is exactly one pre-image, then that function is called one function. Otherwise it is called many one function. See, as I mentioned before, see 5 to 8. Now it is not one function, it is called many one function. Okay, it is called many one function. Okay, so next is onto and into function. Onto and into function. See, what is an onto function? See, onto function means, see here, look at this one. Here, function means every elements in domain has exactly one output, right? Okay, exactly one image. Okay. Here, what is an onto function? Onto functions means every elements of codomain. Every element of codomain has one pre-image. Okay, every elements of codomain has one pre-image. That is called onto function. See here, it is not an onto function. Why? Because see, the elements 2, 10 and 12. See, these two elements have no pre-image, right? Okay, these two elements have no pre-image. Therefore, it is not an onto function. Onto function means, see, all the elements of a codomain have one pre-image. That is called an onto function. Otherwise, it is called into function. Okay, now it is an into function. See, I will write, rearrange it, okay? 5 to 10, 6 to 12. Okay, now see, now it is an onto function. Okay, why? Because all the elements of codomain have one pre-image. Okay, all the elements of codomain have one pre-image. So it is an onto function. Okay, so if a function is not an onto function, then it is called an into function. Okay, now let us do some examples. Okay, let us see this example. If given function f of x is equal to 2x plus 1 and two sets are given, a is equal to 1, 2, 3, b is equal to 3, 4, 5, 7. So here we have to, we are asked to write the domain of the function, codomain and the range of the function. Okay, first we will write the elements of the function. So function is defined as f of x is equal to 2x plus 1. So first we will write, see what are the elements of domain, that is 1, 2, 3. Okay, that is f of 1 is equal to, put x is equal to 1. Okay, f of x is equal to 2x plus 1. F of 1 is, so put x is equal to 1, 2 into 1 plus 1, that is 3. F of 2 is, put x is equal to 2, so you will get f of 2 is equal to 5. Okay, f of 3 is, substitute x is equal to 3, 2 into 3 6, 6 plus 1 7. Okay, now we will write the domain of the function. See, domain of the function is nothing but set of elements of first element, that is a, right? That is a itself. Okay, so domain is nothing but set a itself, right? So that is 1, 2, 3. Okay, so codomain is nothing but set B itself. Okay, that is set 3, 4, 5, 7. So what is the range? Range of the function. Range is nothing but, see, set of all the elements, those who have pre-images, right? That is 3, 5, 7. Okay, so 3, 5, 7. Okay, so domain of the function, codomain of the function, range of the function. Okay, now let us solve one more problem that is very important. Here, prove that the function f from n to n, okay, n means set of natural numbers, n to n defined as f of x is equal to x square plus x plus 1, okay, is 1 1 but not onto function. Okay, we have to prove that given function f from n to n defined as, the function is defined as f of x is equal to x square plus x plus 1. It is 1 1 but not onto function. Okay, so for 1 1, what is an 1 1 function? That is, every image has one pre-image, right? That is 1 1 function, means that is every image, not every image, that image has only one pre-image. That is called 1 1 function. Okay, so here, that means how to define? If f of x1 is equal to f of x2, that implies x1 is equal to x2. Okay, then we say function is 1 1. Okay, if f of x1, that is f of x1 is equal to f of x2, that implies x1 is equal to x2. That is, 1 1 function is to be defined as, if f of x1 is equal to f of x2, that implies x1 is equal to x2. See, this f of x1, f of x2 are about what? Images, right? That means if two images are equal, that means that pre-images are equal. That means images have only one pre-image. Okay, no more than one pre-image. Okay, so here first what we will take? Okay, to prove 1 1 function, we will take f of x1 is equal to f of x2. What we have to prove? We have to prove x1 is equal to x2. Then we can say the function is, given function is 1 1. Okay, so here first we will take f of x1 is equal to f of x2. Okay, what is our function? F of x is equal to x square plus x plus 1. Okay, so here f of x1 is equal to f of x2 implies, what is f of x1? F of x is x square plus x plus 1. So f of x1 is nothing but x1 square plus x1 plus 1. That is equal to f of x2, substitute in place of x, you have to substitute x2, right? That is x2 square plus x2 plus 1. Okay. Now, that implies, see, left side 1, right side 1 will be cancelled. Okay. So, next, what is remaining? take these all these elements left side. Okay, so x1 square, take this left side minus x2 square, okay, plus x1, take this x2 here, so it will become minus x2, that is equal to 1 cancelled, okay, 0. Okay, now see, it is of the form x1 square minus x2 square is of the form a square minus b square, right? We have a square minus b square is nothing but a plus b into a minus b, right? That is, so we can write it as x1 plus x2, okay? So what is here? x1 square minus x2 square, right? A square minus b square. So we can write a plus b into a minus b, right? So x1 plus x2 into x1 minus x2. Okay, plus write as it is, okay? x1 minus x2. x1 minus x2, that is equal to 0. Okay, now that implies here, see, first term, second term, okay? In both the terms, x1 minus x2 is common, so we will take it out, okay? That is x1 minus x2 into what is remaining here? See, we have taken out x1 minus x2 outside. So, what is remaining? x1 plus x2. In second term, we have taken this one outside. That means dividing. Okay. So, what will be remaining? Plus 1. Okay. That is equal to 0. That implies either x1 minus x2 is equal to 0 or okay, x1 minus x2 into x1 plus x2 is plus 1 is equal to 0. So here either that implies either x1 minus x2 is equal to 0 or x1 plus x2 plus 1 is equal to 0. It is impossible, right? So here x1 minus x2 is equal to 0. This implies x1 minus x2 is equal to 0. That implies, I will write it here, x1, we have got x1 minus x2 is equal to 0. That implies x1 is equal to x2. Okay. We have got this one, x1 minus x2 into x1 plus x2 plus 1 is equal to 0. Okay. See here, these all x1 and x2 are natural numbers. Plus 1, that is equal to 0. That is not possible, right? See, we have a, if a into b is equal to 0 means either a is equal to 0 or b is equal to 0 or both is 0. Okay. So here x1 minus x2 is equal to 0 or this one is equal to 0. It is not equal to 0. Okay. So it is equal to 0. x1 minus x2 is equal to 0. That means x1 is equal to x2. Take x2 here. So we will get here x1 is equal to x2. So here what we have taken? See, we have taken f of x1 is equal to f of x2 and we have got x1 is equal to x2. That is, if f of x1 is equal to x2 implies x1 is equal to x2. Therefore, given function f of x is equal to x square plus x plus 1 is 1 1. Okay, it is an 1 1 function. Next, here we have to prove it is not an onto function. Okay, so for that, okay, what is an onto function? Onto function means every elements of codomain. Every element of codomain has one preimage. Okay, that is called onto function. See here, see every element of codomain has one preimage. Okay, that is called an onto function. Means every element, all the elements of a codomain have one preimages. Okay, so here let us take one preimage. Okay, f of x is equal to 1. Not a preimage, image. Okay, we will take one image. Means that is one element of a codomain. Okay, we have taken one element of a codomain. That is f of x is equal to 1. That is image. Okay, so here we have to prove. For onto function, we have to prove it has preimages. Okay, but here we have to prove it is not an onto function. That means here we have to prove this one preimage. Okay, image has no preimage. Okay, so here f of x is equal to 1 means what is our function? F of x is equal to, given function is x square plus x plus 1. Okay. So here we have to prove function is not onto function. That means what is an onto function? Every elements of a codomain have one pre-image, right? So here we have taken one image, that is one element of a codomain. Okay, let us see what will happen. See, x square plus x plus 1 is equal to f of x is 1. Okay, that means x square plus x is equal to 0. Take 1 here, so 1 minus 1, that is 0. That means x into x plus 1 is equal to 0. Okay, that means either x is equal to 0 or x plus 1 is equal to 0. So x is equal to 0 or x is equal to minus 1. Okay, see here we have got x is equal to 0 and x is equal to minus 1. For what? For f of x is equal to 1. That means for the element 1 in codomain has, see, this one is the image. But see, what is our function? Our function is from n to n, right? Our function is from n to n, natural numbers to natural numbers. So here, see here, it is two functions, n to n, okay? Here, no 0, right? Natural numbers means 1, 2, 3, 4 up to infinity, okay? Here also 1, 2, 3, 4, 5, etc. up to infinity, right? So, here there is no 0 and minus 1, right? There is no 0 and minus 1 in domain. That means this one we have taken, right? This one, f of x is equal to 1 means image, okay? Element of a codomain. See, this one has no pre-image in domain, okay? This one has no pre-image in domain. Therefore, see, it has no pre-image. Okay, because see, we have got a pre-image as 0 and minus 1. 0 and minus 1 are not in this set, right? Because natural numbers starting from 1. 0 and minus 1 are not natural numbers, right? Therefore, we say this element, okay, that is this image, okay, this element of codomain, okay, has no pre-image. Therefore, given function is not an onto function. Okay. Therefore, 0 and minus 1 are not natural numbers. So f of x is equal to 1. That is, element in codomain has no pre-image in n or in domain, okay, or in domain, okay. F of x is equal to 1. That is, an element 1, then element 1 in codomain has no pre-image in domain. Therefore, given function is not onto function. Okay, so we have proved given function is 1, 1 but not onto function.